4 redox systems relevant to hydrogen-oxygen fuel cells are shown below. Which statement or statements is or are correct for an alkaline hydrogen-oxygen fuel cell? 1. The reaction at the positive electrode is half O2 gas plus 2 H plus aqueous plus 2 electrons goes to H2O liquid. 2. The overall cell reaction is H2 gas plus half O2 gas goes to H2O liquid. 3. The cell potential is 1.23 volts. A. 1, 2 and 3. B. Only 1 and 2. C. Only 2 and 3. Or D. Only 1. So firstly with this question, we're asked for an alkaline hydrogen-oxygen fuel cell. So we can eliminate anything that's acidic in the hydrogen-oxygen fuel cells. So that would be this and this. Because these two redox systems involve H+, which are protons, and they are in acidic environments. Whereas with alkaline environments, we have an OH- produced. So we're looking at the other two redox systems. So if we were to write the overall equation for these two redox systems, the top equation, that's going to shift backwards because it's more negative, the electrode potential, and then the more positive electrode potential is going to shift forwards. So if we were to rewrite these equations firstly, we would have OH- plus half H2 goes to H2O plus an electron, and then half O2 plus H2O plus 2 electrons goes to 2 OH-. Then if we were to balance these equations, because we want the overall equation, we need 2 of everything in the top equation because we want 2 electrons. And so that means that it's balanced now. Writing our overall equation, we can have 2 OH- plus H2 plus half O2 plus H2O plus 2 electrons goes to 2 H2O plus 2 electrons plus 2 OH-. Then cancelling out, we can cancel out our 2 OH-, cancel out our 2 electrons, and we can cancel out one of the waters. So that gives us the overall equation of H2 plus half O2 goes to H2O. And that is statement number 2. So we know that we're going to have statement number 2, so we can eliminate D as a possible answer. Then, looking at the cell potential, well, the cell potential will be 0.4 minus 0.83, and that equals 1.23 volts, which is number 3. So we can eliminate anything that doesn't involve number 3, which is B. And so the way I've worked out this cell potential is I've taken the most positive electrode potential and I've minused the most negative electrode potential. And this is what you do. Finally, we're left with statement number 1. We can't have statement number 1 because we're looking at an alkaline hydrogen-oxygen fuel cell. And statement number 1 involves our H+, which is related to an acidic hydrogen-oxygen fuel cell. So we can eliminate statement number 1. And that means we need to eliminate A. And so the answer for this question is C. And to get the mark for this question, you must write C in the answer box provided.